Hey everybody, welcome to another Mathnificent conversation. Today's featured guest is factoring out the greatest common factor. When we factor, we start with terms. Terms are things that are added or subtracted. So I'm going to show you here. We're going to start off with something where a series of terms are added or subtracted, but then we end up with two things that are multiplied. Now, the things that are multiplied might also have terms, but we go from adding and subtracting terms to two factors that are multiplied. Our first step is going to be to identify the greatest common factor. And we're going to do that by taking each term and doing a prime factorization. If you need help with prime factorization, check out the prime factorization video. Once we identify the greatest common factor, we're going to divide the greatest common factor out of each term. So I'm going to start with showing you the long way that shows how this works, and then we're going to move how you should eventually be able to quickly identify the greatest common factor and divide it out of each term. So let's factor out the GCF of the expression 4x minus 8. Okay, so I'm going to break this down into its prime factorization. 4 is 2 times 2 times x minus, and then 8 is 2 times 2 times 2. When we say greatest common factor, we're saying what factors does each term, remember this is a term and this is a term, have in common. So my first term, I see I have two 2's and an x. My second term, I also have two 2's and an additional 2. But what they have in common is two 2's. So we're going to take the two 2's and divide them out. And if I divide them out, let's say 2 times 2, what's left, if I divide out of my first term, I'm left with x, minus if I divide them out of my second term, I'm left with 2. So my final answer is 4 times x minus 2. And you'll see now we end up with two factors, 4 being the first and x minus 2 being the second. Okay, let's look at the expression 3x squared minus 24x minus 51. So this expression has three terms, 3x squared, negative 24x, and negative 51. 3 is already prime, so times x times x. 24 breaks down to 2 times 2 times 2 times 3, and then times x. And 51 is 3 times 17. So then I go back and I say, what does each term have in common? Only the first two terms have an x, so I know x is not part of my greatest common factor. Only the middle term has 2's. Only the last term has a 17, but they all have a 3, which means I can divide 3 out of each term, and I'm left here with x squared minus 8x minus 17. And now the expression I started with has factored into 3 times x squared minus 8x minus 17. Okay, now we have an expression with 4 terms, 5x to the 4th, 10x cubed, negative 25x squared, and negative 5x. So we're going to do prime factorization of each term. 5 is prime, and then we have 4x's multiplied. 10 factors to 2 times 5, and 3x's multiplied. 25 is 5 times 5 times 2x's. 5 is already prime, and x is already prime. Okay, so let's see what we have in common. Each term has at least one x. So I have 1x here, 1x here, 1x here, and 1x here. And only one is possible. It can only be the smallest amount because each term has to have that common factor. So the only common factor in terms of variables that each term has is 1x. And each term also has a 5. So we can divide out 5x, and we divide out 5x. The first term we're left with x cubed. The second term we're left with 2x squared. The third term we're left with 5x. And the last term, this is one that trips students up a lot. 5x divided by 5x is 1. Remember, we're dividing the 5x out. It does not disappear. It becomes negative 1. So our two factors are 5x, and then the quantity x cubed plus 2x squared minus 5x minus 1. Okay, we have an expression with 3 terms, but numbers and 2 different variables. So 2 times x to the 4th y cubed, 4x cubed y squared, and 4x squared y. We're going to do our prime factorization. 2 is already prime. X to the 4th factors to 4x's multiplied. Y cubed factors to 3y's multiplied. 4 factors to 2 times 2. X cubed is 3x's, and y squared is 2y's. 4 again is 2 2's. X squared is 2x's, and y is already prime. Let's check and see what we have in common. I see that each term has at least 1, 2, so I can factor out 1, 2. Each term has at least 2 x's, so I can factor out 2 x's. And each term has at least 1 y, which means that my greatest common factor is 2x squared y. And if I divide that out of each term, the first term I'm left with x squared, y squared. My second term I'm left with 2xy. And my third term I'm left with 2, and that's it. So our term factors into 2x squared y times the quantity x squared y squared plus 2xy plus 2.